So this problem is on reversing a digit, and the problem statement is simple as usual. Given a decimal number, we're going to return a new number with the digits of the original number in reverse. We're going to preserve the sign. So as a quick example, if we take 134 as input, what we're going to return is obviously 431, right? And if we have a negative number, so negative 134, then we're going to preserve the sign and return negative 431. Okay, so the problem is simple enough to understand, and the solution is the tool, the hint we're going to use is the modulo operator, along with addition, along with multiplication and addition and division, integer division. So decimal number is, so it's base, it has a base 10. So if we want to extract out the last digit, we are going to use modulo, the modulo operator. So modulo gives you, say you have 134, then if you modulo 10, it would give you the last digit, which is 4, right? So our strategy is to always extract out the last digit in the remaining number, and we're going to put that in the place that it is supposed to be. So if it's the last digit, we're going to put it as the first digit of the number we're going to return. And the second is going to be, the second to the last is going to be the second digit in the number we're going to return. So first we're going to extract out the last digit with this operation. And then we're going to move this digit to the right, to the left by one place. So in decimal, it means that we have to multiply it by 10. So 4 multiplied by 10 gives you 40. And then we have the least significant bit, the least significant decimal place left open, where we could just use add to add the second to the second digit to the number on the 10th place. So then we could just use the modulo operation again. Say if we have 13 left, and then we're going to modulo that with 10 again. So this gives you 43, because this is going to extract out 3, which is the second digit, which is the digit on the 10th place. So we just iterate through until there's nothing remain in the original digit. Then we end. And another thing to note is that we use integer division to get rid of the last digit so that we could obtain 13, and we could use 13 to modulo 10. So the entire loop will look like this. So if we just focus on the loop here, first we're going to so move the current result to the left by 10 so that we have room to put in the last digit in the current remaining number. So and then we're going to take the last digit. It's the same as here. And then we're going to integer division the remaining digit by 10 in order to get rid of the last digit so that we can move on to extracting out the last digit of the remaining number. And then once we're finished, once the entire digit has been, every digit in the entire input has been removed, which is to say that, if we reach the very front of the original number, which is obviously something between 1 and 9, and that integer division by 10 would give you 0. So when x remaining becomes 0, then we're going to stop the loop and we're going to return. And to deal with the sign, it's also very simple. So we always just deal with the absolute value to avoid any problem with modulo, because modulo could be weird with a negative sign. and so we just deal with the absolute value. And once the digits, the absolute value of the original number has been uh, correctly reversed, then we're just simply going to add a sign if the original number is less than 0. So this would give us the correct result of reversing the digits